Tessa and Iris. So for Tessa and Iris, since they're gone. All right, so this is the, what? Oh, shalom. Just kidding, this is not for you anymore. Okay. Let's restart that. No. All right, 8.4, graphing rational functions. When we deal with more complicated rational functions, there are cases when finding the horizontal asymptotes. Okay, so ideally, we want to graph rational functions. First, what is a rational function? What does it even mean? What is a rational function? I'll give you a hint.
When we deal with more complicated rational functions, there are cases.
It's a ratio of two polynomials, aka it's a fraction. So a rational function is literally a fraction with polynomials on top and bottom. What's a polynomial? Two or more numbers, terms. All right, so let's talk about how to graph them. So first, this is a polynomial. I'm sorry, this is a rational function. I have a binomial on top, a binomial on bottom. All right, have you guys ever seen something like this? It's weird. It's a little curve. It's going off to infinities. A great idea if you're Alex this week is pick rational functions. That would be a great idea. All right. So notice that there's this dotted line vertical, and we've dealt with those before. What do we call them? Yeah, so this was a vertical asymptote. And let's think back. What does a vertical asymptote mean? Almost touches but doesn't. Right, you can't cross or touch. So we've dealt with vertical asymptotes before, where you have a dotted line and you will get really close. It's that freeway median where you get super close to it, you don't touch it. You can get super close to it. So we've dealt with vertical ones before, and now it'd be nice to deal with the horizontal ones. So the horizontal ones determine what happens at the ends of the graph. The very left side, the very right side of the graph is the horizontal asymptote. That's what deals with that, horizontal asymptote. Okay, so here, the vertical asymptote is at x equals 3. So it's literally a vertical line at x equals 3. The horizontal asymptote is y equals 2. Because if I draw y equals 2, that's going to be a horizontal line. X equals 3 is a vertical line. All right, so far with me. I apologize if this is a little slow. I'm just trying to make sure we're together as we go into the promised land of rational functions. Okay, so let's try this. Example 1, let's just get right to it. Graph the rational function f of x equals 2x over x plus 2. Okay, how do you even do that? So I put the directions on here for you. Note the homework will not give you these steps to follow, but this is what you should do. This is what you should find for each graph. Find the zeros, aka set the numerator equal to 0. All right, so which one's the numerator? 2x. Okay, so I set 2x equal to 0. How do I get x by itself? Divide by 2. What is 0 divided by 2? 0. Okay, cool. So I know that my 0, when y equals 0, x is going to equal 0. So I'm going to go ahead and I'll put a dot here. Find any vertical asymptotes. So how do I find the vertical asymptotes? Set the denominator equal to 0. Man, it's like I wrote it for you. Okay, so let's take the denominator. That's the bottom one. So the bottom is x plus 2. So I set x plus 2 equal to 0. To get that x by itself, subtract 2. So I have x equals negative 2 is the vertical asymptote. Let's go down here. So at negative 2, at x equals negative 2, I'm going to do a vertical dotted line because that is my vertical asymptote. Okay, so far so good. Part C. Find any horizontal asymptotes. Okay, so hold the phone. We haven't really done that before. But what we have done is we've talked about leading terms. What is a leading term? We're looking at the highest degree. So I'm looking at the leading terms. The leading terms are the terms with the highest degree. So leading terms have highest degree, meaning they have the biggest exponent. So I'm looking at 2x and x. So which is bigger? Which one has a bigger exponent? The 2x or the x? They're the same. So wait, if I plug in bigger and bigger and bigger x values, this little plus 2 goes away because it doesn't really matter. When I'm looking at 100,000 and I'm adding 2, that's not much of a difference. So I'm looking at 2 times a big number, divide by that big number. What does this equal? 2. So I have a horizontal asymptote at y equals 2. Go over it again? Yes. So to find horizontal asymptotes, you look at the leading terms. So the leading terms are the ones that have the highest degree, aka the ones with the biggest exponent. So I'm looking at my function. On top, I only have one term. It is 2x. So that is the term I look at on top. On the bottom, I have x. That's the highest, that's really the only x term I have. So I'm looking at 2x divided by x. The x's cancel out, and I'm left with 2. So I know it's going to take another example or two for this really to sink in. Because if you think about it, if I put in a really, really big number, right? So let's say I put in x equals 1,000,000. So I would have 2 times 1,000,000 on top over 1,000,000 plus 2 on bottom. So really the plus 2 doesn't really matter when I'm talking about really big numbers. So what I'm dealing, okay, so let's think about this another way. So you guys are in history class, right? Y'all are in history? Think about the wars in Europe. All the little feudal lords fighting, right? There's lots of little factions. Who ends up winning the war? The biggest army ends up winning the war. So if I have this big polynomial on a rational function, which polynomial, which term is going to win the war when x is getting big? The one with the highest exponent. So I'm only looking at the highest exponent on top and bottom because those are the ones that really matter. If you're thinking about x to the 6th power versus x to the 5th, which number will be bigger? To the 6th. So that's the one that turns out dominating. So we're looking at the ones with the highest degree. So it's a leading term test. Next year you'll go into this a little further. So we look at the highest terms, I set them on top of each other, and I see what happens. Do the variables cancel out? Am I left with a variable on top, or am I left with a variable on bottom? Those are your only 3 cases. If the variable cancels out, I'll just have the coefficients. Here I have 2 over 1, so I'll have a horizontal asymptote at y equals 2. So this section, if you look in your book, it talks about horizontal and vertical asymptotes. Those are the 2 we're doing. It also talks about oblique. If you think about the obliques on your body, what does oblique mean? So if I have vertical, I have horizontal. Oblique is your obliques come around your rib cage. They're at an angle. No, we don't know obliques. Okay, that's cool. Whatever. It's been 8 years since I took anatomy. I still remember obliques. Okay. So we're not going to do oblique asymptotes, but we are going to do horizontal vertical. We already know how to do the vertical ones. Check. We learned that. The whole idea of today is how to do horizontal asymptotes. And once you have those two asymptotes, you just draw in these little curves. And we just have to decide where the curves will be. Okay, find any horizontal asymptotes. We did that. And then graph the function. So I already have 1 point. Right, remember if I plug in 0, for x, what do I get for y? If I plug in 0 for x, what do I get for y? Nope.
Oh, 0.
Right. If I plug in 0 for x, because I have 2x over x plus 2. Okay. 2x over x plus 2. If I plug in 0 for x, I get 0 for y. What if I put in 1 for x? I get 2 over 3. What if I put in 2 for x?
Then you get 4 over...
Oops, 4 over 4. What if I put in negative 1 for x? Negative 2 over 1, which is negative 2. So let's see, 2 comma 1, negative 1 comma negative 2. So it comes around this way. Let me pick a different color so that way it's not so confusing.
What you're saying is that you can leave out the first. Or we included this.
I included it when I was graphing. So when I put in 1, I have 2 times 1 over 2 plus 2, so that's 2 over, wait, oops, sorry, that's supposed to be a 1. 2 over 3. Here, when I put in 2, I have 2 times 2 over 2 plus 2, so that's 4 over 4, which is 1. I put them in. I'm using the actual function to figure out what it should be like. So if this is, and then I just connected the dots. Rational functions are going to be these like curves that follow the asymptote. Because remember, when I was making this, I connect the dots, but I can't cross the asymptote, right? I can't actually cross this asymptote. So I have to get close to it, but not cross it. So I can't cross it. I drew my asymptote. I get super close, but do not touch. What? I get super close, but do not touch it. I don't know why this is so slow. It was so fast yesterday. So I'm following the asymptotes. I get close, but do not touch. Okay, so what about the other side? Is my graph, yeah. Is my asymptote going to be up here, or is it going to be down here? It's coming. Where is my graph going to be? Is it going to be in the second or third quadrant? How do I know? How can I figure this out? Maybe. I mean, it is, but I want you guys to think about it. Let's plug in, how about negative 4? If I put in negative 4, I have 2 times negative 4 over negative 4 plus 2. So negative 4 comma 4. So I picked 4 because it's on the left side of my vertical asymptote. And since I have 1 point up here, the things I care about, accuracy-wise, I want the horizontal asymptote exactly. I want the vertical asymptote exactly, and I want you to have the right side of the asymptote.
How do you know if it's right?
So it's on the left side of the vertical asymptote.
So if you plug in a different number and it wouldn't fit in the
So if you picked negative 7, it would still be on that side.
But why didn't you pick like positive 3?
Positive 3 is on the right side of the asymptote. I already have it graphed. Positive 3 is right here. I already have positive 3 graphed. Right there. Yeah.
So now you're just like picking numbers that are on the other side of the asymptote.
Yep. To see where the swoosh will go.
And will it always go up and down?
So they might be both on bottom, they might be both on top, they might be opposite. I plugged in one number and I figured out which side it would be. Because remember, I can't cross the asymptote. I only can get super close to it. So I didn't need to plug in 3 numbers. I didn't really need to plug in 3. I honestly, once I found this guy, that was all I needed, because as I go to the left side, I can't cross the asymptote, so I go down. And then as I go to the right, I get close to the asymptote, but I can't cross it. I only needed 1 point, so I had everything to the right of x minus 2 graphed. So I picked a number on the left side, and it tells me if my swoosh is up here or if my swoosh is down here. Things I care about accuracy-wise, I want the exact vertical asymptote, I want the exact horizontal asymptote, and I want you to have the right side of the asymptote. I want the swoosh to be in the correct area. Alright, so if you drew the swoosh down here, do you know what I mean by a swoosh?
Yeah.
The line. If you drew the line down here, X-nay, that's not right, but it's up here, cool. I don't want you to be bogged down by having to find like 15 different points. Like, that's a pain in the butt, right? As long as you have 1 point, you follow the asymptote, do not cross it, 2 thumbs up from you. This one, this is like super accurate because we found 3 different points. Alright, let's do another example. Yeah, okay. This is, it's pretty much the whole thing is just find the vertical asymptote, find the horizontal asymptote, see if we have a x-intercept. Case 2. Alright, so this case 1 was, well, how did I know what to do? I literally told you to find the horizontal asymptote, put the leading coefficient in the numerator over the leading coefficient of the denominator. So remember, leading coefficient is just the biggest degree. It's the term on top with the highest exponent, term on bottom with the highest exponent. Alright, case 2. If the degree of the polynomial in the denominator is greater than the degree of the numerator, the horizontal asymptote will always be 0. So what does that even mean? What does this mean? Degree of the polynomial in the denominator. Like, in English, what is this saying? Well, I mean, it is a difference of squares, but the degree in the denominator greater than the degree in the numerator, meaning if I have like an x over x squared, the exponent on bottom is bigger than exponent on top.
So it's a high series polynomial.
Maya, sit up, please. What? Jonah, sit up. Right, so when I cancel out one of my x's, I have 1 over x. Because this is, technically, this is x over x times x. And and when I graph 1 over x, this gets closer and closer and closer to 0. As I put bigger and bigger numbers in for x, the overall number gets smaller. So think about it, right? 1 over 2 is bigger than 1 over 5. Right? So 1 over 2 is 0.5. 1 over 5, 0.2. 1 over 10, 0.1. 1 over 100, 0.01. So I'm getting smaller as I'm putting bigger x's on bottom. That's why the horizontal asymptote is at 0. So if I put a really, really, really big number on bottom, this gets closer to 0. Okay, so what do we do? The horizontal asymptote will always be y equals 0 if you have a bigger exponent on bottom. So you draw your horizontal asymptote right here. Which is kind of hard to see. Alright, so notice we have 2 vertical asymptotes. So that was what you guys were talking about. We found our vertical asymptotes by finding the zeros of the bottom of our rational function. Okay, so let's do example 2. Consider the rational function 5 over x squared plus 4x minus 5. Find the zeros. Does someone want to lead me through this, how I do this?
I can try.
Alright. Yeah. Set the numerator equals 0. Okay. So how would I do that?
So you would do 5 equals 0.
5 over x.
Equals 0.
I'm just trying to factor in this. Factor this?
You could do Yeah, negative 4 and 1. Wait.
So it adds to 4 and multiplies negative 5.
Yeah, negative 5. No, positive 5 and negative 1.
Perfect. So x plus 5, x minus 1. So if I set these equal to 0.
0, so it would be negative 5 and positive 1.
Awesome. So I see that x plus 5 cannot equal 0. Because if it does, that term on the bottom goes to 0. And we don't want the bottom of our fraction to go to 0 because it will be undefined. Remember? Don't want the bottom of a fraction to go to 0. So x plus 5 cannot equal 0, so that means x cannot be negative 5. Similarly, x minus 1 cannot equal 0, so x cannot equal 1. Oh shoot, I'm sorry. I was doing the wrong one. I was doing b. I was saying the denominator equals 0.
Okay.
Just a second, let me move it down. That way it's not totally confusing.
We'll see.
Should have read the directions. I was doing b. I was saying the denominator equal to 0. To find my vertical asymptotes. To find the zeros, I set the numerator equal to 0. Okay, so the numerator is 5. If I set 5 equal to 0, wait, what? That doesn't make sense. 5 can't equal 0. So there are no zeros. What do I mean when I say zeros?
It doesn't have 0, 0.
So there's no x-intercepts. That's what this means. Doesn't necessarily have to be 0, 0. It just means I'm not going to have a point at y equals 0. And the whole reason is because if I look at the degree on top versus the degree on bottom, what will the horizontal asymptote here be? What will the horizontal asymptote here be? So you find the zeros. To do that, you set the numerator equal to 0. What's my numerator here? 5. Okay, so I set 5 equal to 0. Is 5 equal to 0? No. So that tells me there's going to be no zeros, no x-intercepts. There's my graph, my line is not going to touch the x-axis. And I found my vertical asymptotes by saying the denominator equal to 0. It's what Jonah and I were doing earlier. So, we want to find any horizontal asymptotes, aka what's the degree of the polynomial in the numerator and denominator. So on top, I have literally a degree of 0. Because it's 5. Literally, it's 5 times x is 0. It's just 5 by itself. So that's a degree 0. And on bottom, I have x squared, so that's a degree 2. If you have a higher degree on bottom, what is my horizontal asymptote going to be? My horizontal asymptote? If the degree in the polynomial in the denominator is greater than the degree in the numerator, the horizontal asymptote will be y equals 0. Sorry, where? All right. So notice that there's no x on top. I literally have 5 by itself. Even if I had like 5x, the degree in the bottom is bigger. If you have a higher degree in the denominator, your horizontal asymptote will be y equals 0. So when I go to graph this, I'm going to do a line at y equals 0. Sorry, do you want me to go back up? I have a horizontal asymptote there. And then I have 2 vertical asymptotes. Where are my vertical asymptotes, Jonah?
Y equals 0.
So my horizontal, I'm sorry, that was my horizontal was y equals 0. I meant vertical. So my vertical asymptotes are going to be x equals -5 and x equals 1. Sorry, I was not saying what I wanted. Okay, so I have like 3 different asymptotes on there. This is crazy. Soup's crazy. Right. All right. So we have our asymptotes. We know that our line is not going to touch the x-axis at all because we have an asymptote there. How do I decide where the swoops are, where my lines are? How do I know? What do I do, Matt? Do you have an idea? Well, we're trying to graph. So we're going to plug in some numbers. What would be an easy number to plug in? 0. Let's plug in 0. So, okay, I'm just going to write this so I don't have to scroll back up. 5 over x squared plus 4x minus 5. Okay. If I plug in 0, what is my y value? Negative 1. So I put a dot here. Guess what? I have to follow the asymptotes. Remember, I can't cross them, so it goes down this way. I come up, I can't touch the asymptote, and I come back down that way. Yep.
So if you do the problem and you get, so can it not be 1, or can you not plug in the number?
I can't plug in x equals 1 because that's an asymptote. I won't have a value.
Okay.
So I can't plug in my asymptote values. What would be another good number to plug in? How about 2? 2, maybe? Plug that in. 5 over 2 squared plus 4 times 2 minus 5. How am I picking these numbers? Different sides of the asymptote, exactly. I tried to pick easy numbers for myself. So pick 0 because that will make my x's go away. All right, pick 0, found this point, and then I follow the asymptotes to fill it in. Let's see. If I plug this in, I have 4 plus 8 plus 12 minus 5 is 8, 5. It's going to be positive. It's going to be up here. Okay, because it's, let's see, 5 over 12 minus 5, 5, 7. So it's going to be a little more than 1, something like this. So remember last time, the things I care about in accuracy. You must have your vertical asymptotes exactly correct. And it would be great if you labeled them. You must have your horizontal asymptote exactly correct. And then you just need to make sure your lines are on the correct side of the asymptote. So I'm going to repeat this to make sure we're clear. The line is up here. It should not be down here. Down here is wrong. Up here is correct. And look, I even have proof. I'm only going to plug in one number. I'm only going to plug in one more number, and then I'll decide, should it be down here, or should it be up here? We shall see. So what would be a good number to plug in so I can figure out which side it's on? -6, -8, anything that's on this side of the asymptotes. I'm trying to figure out what's happening here. I don't care. Let's maybe do -6. There you go. Oop, what is going on here? Oh my gosh. Oh gosh, that's not what I wanted at all. Oops. Okay, exciting. I don't know how that happened. Okay, well. Okay. So if I'm gonna plug in, oh geez. I don't know what's happening. Okay, cool. So let's plug in x equals -6. So I have 5 over -6 squared plus 4 times negative 6 minus 5. I just want to know, is this positive or negative? Let's see. 5 over 36 minus 24 minus 5. Is this going to be a positive or negative number? 36 minus 24 is 12. 12 minus 5? 7. 5 7, so it's positive. Surprise. Okay. Oops, I didn't mean to make that different color, but you get the gist. Beautiful. Beautiful. So finding vertical asymptotes, set the denominator equal to 0. Finding horizontal asymptotes, look at the leading terms. Find the x-intercepts, set the numerator equal to 0. Finding which way the line should go, which way you should be swooping, you just plug in a number and see on which side of the asymptote you are, and then follow your asymptote to make your line. Let's do another example. Let's do another example. Sure. Do you guys need like a 2-second break? I gotta pause. Let's go through this next example. Consider the rational function blah. Find the 0. Set the numerator equal to 0. First step. Someone will lead me through this. How do I do this? All right. Go ahead.
So x plus 1 equals 0.
Oh my god.
Subtract 1 and make x equals negative.
Okay, so I set numerator equals 0. X plus 1, set equals 0. You said subtract 1.
So now you're going to set the denominator equals 0, but in order to do that, you make a factor. So you would make this one x plus 4 plus 4 now x plus 6, x minus 2, and then x cannot equal negative 6, and it cannot equal positive 2.
Awesome. So we have vertical asymptotes.
So now you can start, you can put those down.
You draw them. Let's see, negative 6 and 2.
And you also have the horizontal.
Oh yeah, we have to, let's see, this is
So not yet. You
x equals negative 6, x equals 2. Okay, labeled my asymptotes. Need to find my horizontal.
okay. So what is the big one in the numerator? So in the numerator is x plus 1. So that's 1. Or then 0.
That's a degree of 1. Sure.
And at the bottom, is 3.
2. X squared, the degree is 2. Literally what the exponent is. I'm not adding what the total exponents. I'm looking at the highest one, highest number.
Okay. So then you use your class to put online.
So what is my horizontal asymptote? Close. Y equals 0. When you have when the degree, so I'm only going to give you 2 cases. Either the degrees are the same, and you take the ratio of the exponents, literally, you cross out your x's and you'll just have the coefficients. Or the degree on bottom will be higher, and you'll have a horizontal asymptote at 0. Those are the only 2 cases I'm giving you. Either the exponents will be, the highest exponent on top and bottom will be the same, they'll cancel out and you'll have a constant number, or the exponent on bottom will be higher and you'll have your horizontal asymptote at y equals 0. Please open the door. Okay. Alright, so I have a horizontal asymptote at y equals 0.
So you can go to that too. No.
Yep.
And
Is this enough? Can you guys see? I want to make sure you're writing this down. Is it too small? Is this too fast? Do we have more time to write this down? think we covered that pretty well. All right, Ari, how do I finish this out? How do I actually graph this guy?
So now we're going to pick a number that fits in top box. I want x to be negative.
All right, so we're picking -2. That way we're looking which of these two sides it will be on. Will it be on the top or bottom? Okay, so you put in -2. Exactly. So it's in the positive. It is. What's our, did we find a 0? Where was our 0? Right, so interesting, because, okay, so if I pick -2, it's going to be like a little bit higher. So if I follow the trend, it gets higher and higher. I follow the asymptote, follow the trend, this goes down. So I'll pause here because this is confusing. What the heck is going on here? Right? So I crossed the horizontal asymptote, but I thought that's not allowed. Weird stuff. Vertical asymptotes are like Gandalf. You actually cannot pass them. Horizontal asymptotes are all about the end behavior. They're all about the right side and the left side. So I'm going off to infinity over here, I can't cross it, but it doesn't say anything about the middle. So horizontal asymptotes, you could technically cross in the middle. The only time you can't cross them is the end. I know. What the hell is this, right? So mad when I found that out. I was like, why? Why call it an asymptote? You should call it like an asymptote sometimes. Right? As sometimes. Just call it a sometimes. Alright, so the sometimes, horizontal sometimes, you can cross in the middle, you can't cross it again. I'm just as mad as you are, but unfortunately it's not that word.
So this graph goes into both lines?
So, right, so this one, you literally cannot cross the vertical, you can cross the horizontal only in the middle.
So it's
But the only time you do that is if you have more than one vertical.
Yeah, I was gonna say, you can only do that with between two verticals.
Right. You can only do it if it's between two verticals because,
Sounds like I'm the person who made them, they found themselves in the box.
no, right? Why call it an asymptote if it's not real? It made me really mad. As you can tell, I'm heated. Alright, so the horizontal asymptote only cares about the ends. Alright, so we have that part done. Next, what should we try?
Let's try and see what goes
Alright, so on the right side of the vertical asymptote,
5.
what are you picking? 5?
Yeah.
Okay, so I have 5 plus 1 over 5 squared plus 4 times 5 minus 12.
So 5 squared is 5 plus 20 minus 12.
Is this going to be positive or negative? Positive. Okay, so it's going to be up here.
30,
5 plus 1
33. So 33 so 33.
Should I make it more accurate?
No.
Because I just care about being on that side of it. You see what I'm talking about? I follow the asymptotes. I follow the asymptotes here, so I'm like close to it. Because it doesn't have to be like super perfect. Because the things I'm looking for, exactness, your vertical and horizontal asymptotes must be 100% exact. They must be dashed. You must label them. I want to see, because the things that make you find, like, oh, the x-intercept, that is exact. Notice I put that big dot there. And then I found the -2, that way, like, how did I know it was not going this way, and it was going this way instead, right? I picked the number, and I was like, oh, okay. Follow the trend, follow the trend. Here, I know it's up here. So now we have to decide which side of the asymptote is on, right?
I understand why it's allowed. I don't know why. Like, how did you get 0?
So this, from the first part where we said our numerator equal to 0, we found our zeros. from part
It's
A.
just negative 1. So
Yeah. 0, negative 1. Alright. Should we plug in like negative 7, negative 8? What do you think?
Negative 10.
Negative 10? I mean, that's fine. It will tell us which side it's on. So I put in negative 10. Okay. So I have negative 10 plus 1 over negative 10 squared plus 4 times negative 10 minus 12. Okay, so negative 9 over 100 minus 40 minus 12. Is this positive or negative?
Positive. Negative 9 over negative 4.
Negative 9 over a positive number, so it's going to be negative.
So you could just
Oof.
something in the bottom.
So it's going to be down here.
And that's it.
Because let me, this is one of the SAT skills. You don't have to do like every calculation to fruition. Alright, so I put in the negative 10 on top, so I knew I had a negative on top. Will the bottom be positive or negative? 100 minus 40 minus 12, okay. 100 minus 40, 60 minus 12, 48. Okay, so it's positive. A negative over a positive is going to be negative, and that's how I knew it was down here. Because a negative y value is on the bottom side. So that's how I knew it was down here.
Thank you.
Alright. Follow along. Why are you following along to the notes? Let's see. Let's keep going. Alright. What? Okay, just try to take some notes and stay awake, because you lose participation, yeah? Yeah. Which part? Alright. Cool. So we did that. We're not doing oblique. Okay. You good? Okay. So we make sure I have enough time to try one of these at least. Let's skip example 4 and let's go to example 6. What was that, our third or fourth example of graphing? So a point of discontinuity is something, what does continuity mean?
Like continuous.
Continuous and flows. If it's a discontinuity is a hole, it's not continuous. It's when you're driving along and then a squirrel flies out in front of you, so you slam on your brakes. Like all of a sudden you're not flowing anymore. You're like, stopped. No. No. I cried the first time I hit an animal. Yeah. One time I hit a turkey and broke my mom's bumper. Yeah. Yeah, they're thick. Alright, so my point of talking about hitting turkeys is points of discontinuity. Literally, the graph is going, then all of a sudden there's a hole. What the heck? Like there's a hole, or it's going to infinity. So in the numerator and denominator have a common binomial factor, aka there's a factor on top and bottom that can cancel. That is where a hole will be. That's a point of discontinuity, it's a hole in the graph. So from now on, you must always check for holes. Make sure that a factor does not cancel. So hint, factor and simplify first. So let's try this out. How can I factor the top? How can I factor the top? Yeah, it's a difference of squares. It's a difference of squares. So I can say f of x equals x minus 2 times x plus 2 all over x minus 2. So factor and simplify. How would I simplify this?
Would you just go backwards?
Okay. Cancel that out. But in order to cancel that out, I have to make sure I state that x cannot equal positive 2. Alright, so if something cancels out, I know I have a hole at x equals 2. If the factor cancels out, that's where you have a hole. If the factor cancels out, that's where you have a hole. Okay, So we factor it out. So now we have our simplified version, which is f of x equals x plus 2. All right, so let's find the zeros, set the numerator equal to 0. What we're going to be doing is looking at our simplified fraction. So let's look at our simplified fraction, aka I'm looking at f of x equals x plus 2. So I set it equal to 0. Find the zeros, set it equal to 0. X plus 2 equals 0, so in order to solve for that, minus 2 on both sides, x equals minus 2. So I'll go ahead and put a dot there at 0, comma, negative 2. That is a 0. Now I want to find the vertical asymptotes. So I'm looking at my simplified fraction. Do I have a denominator? No. So do I have any vertical asymptotes? No, I have no vertical asymptotes. Because I canceled out the one factor, I don't have any other factors remaining. It is possible to have a whole and a point where it's going to infinity, like one of those vertical asymptotes. This example, we do not. So I'm starting off slow with the whole. All right, find any holes. We already said the x minus 2 factor had canceled out on top and bottom. So that means our hole was at x equals 2. What would the y, what's the x comma y coordinate of the hole? We know what the x value is, 2. So how would I find the y value? Plug it in to my simplified fraction. So 2 plus 2 is 4. So the coordinate of my hole is 2 comma 4. Okay, so let's go down here. 2 comma 4, make a little circle for a hole. Are we there so far? So I plugged it back into the simplified function. The simplified function was x plus 2. So I'm taking the x value of my hole, plugging it in to see what the y value should be. Huh? 2 comma 4. All right, let me make that a smaller hole because that's crazy. That's so crazy. Okay, here we go. I have the x-intercept. I have the hole. I need to find the horizontal asymptote, but I canceled out a factor, so now I no longer have a fraction. Right? I have a straight line. I have the x plus 2 straight line, just with a little hole. So what's the horizontal asymptote? I have none. I have no horizontal asymptote because I no longer have a fraction. And when I say graph the function, you want to graph the simplified version. Which is f of x equals x plus 2. What does this, how would you graph this? This goes back to chapter 1 or chapter 2. Y equals mx plus b. What's the y-intercept?
4.
2. The y-intercept is 2.
Oh.
The slope? Slope's 1. Slope 1, slope 1, slope 1, over 1, down 1, over 1, down 1. Up 1, over 1, up 1, over 1, up 1, over 1. The m, which is the slope, is 1. This is putting everything together that we learned this year. We have the b, which is the y-intercept, and that's at 2. Let me zoom in and make this so it's not so nasty. Okay. Why does this look so bad? So notice this is a straight line with a hole. That's it. That's the whole thing. It's a straight line with a hole. We call this a point of discontinuity because it's kind of like you took your paper, poked a hole in it. That's it. Little circle. How do we feel about this so far?
I understood it's a fairly important sentence. You just go up with this. It's like you laid out most of us, and then you started breaking them.
What?
Again.
What'd you say?
You laid out the rules, and then you started breaking them.
I didn't break, only like once, and that was a horizontal asymptote, and I've warned you.
I understood it until you started doing like the slope or something, like the line or stuff like that.
Well, because I wanted to graph y equals x plus 2. So I'm taking you back to chapter 2. Let's do example 7, since we have 6 minutes left. It goes till 10. So we have enough time that we'll do example 7. It's not too long. But it puts the whole thing that we did today and this year together. So first, I want to factor and simplify this out. So f of x equals x minus 3 over, if I want to factor the bottom, right, so what multiplies the negative 6, adds to negative 1, be negative 3 and 2. So I have x minus 3 and x plus 2. This time, when I cancel it out, I still have something on the bottom, right? So my simplified version is now 1 over x plus 2. What doesn't? I cancel out the one factor, and I still have the other factor. So I have 1 over x plus 2. So if I try to find the zeros, I set the top of my fraction, the numerator, equal to 0. But wait, what? 1 cannot equal 0, so there's actually none. There are no zeros, no x-intercepts. If I wanted to find the vertical asymptote, how would I do that? Set the bottom equal to 0. So x plus 2 cannot equal 0. Because if it does, we'll have undefined. We'll be dividing by 0. Meaning x cannot equal negative 2. Awesome. So I'm going to come down here, do a little vertical asymptote at negative 2. Just so I can see it. Okay, this is my vertical asymptote at x equals negative 2. Okay, I want to know, where do I have a hole? Where is my hole? It's the term that canceled out, the x minus 3. It's the factor that canceled out. So I'm going to have a hole at x equals 3. What will the y value here be? So in order to find that, I plug this back into the simplified version. Exactly. My hole is at 3, 1/5. Come down here, 3, 1/5. Oh Lord, it's like right there. Okay. Find any horizontal asymptotes. Okay. How do we find a horizontal asymptote? Look at the degree. So I have a degree of 0 over a degree of 1, right? Because 1 over x plus 2. So since the degree on the numerator is bigger, denominator. Oh, the degree of denominator is bigger. I'm going to have a horizontal asymptote at y equals 0. Whenever the degree on bottom is bigger, horizontal asymptote is 0. And lastly, graph the function. So we already have 1 point. Right, so remember our hole is above this. It's at 1/5. So I follow the asymptote, I don't touch it. And then I just have to figure out what's happening on the left of my vertical asymptote. So if I plug in a number like x equals negative 3, what would y equal? One over negative 1. So it'd be down here. So it's below. So I know it's negative, so that means it's going to be below. It's not perfect, but this is... But really, I care about vertical asymptote exactly, horizontal asymptote exactly, and which side you're putting it on. So notice I didn't do it exactly, but super close. That's the part I care about. Awesome, and then that's it. The homework is the 8.4 handout.